Mr. Amayanti. Am I audible?
Yes, we can hear you.
Good afternoon and good morning to everyone from all parts of the world who are joining this Frontier Labs E-Symposium on analytical and applied pyrolysis. It's my real pleasure to be chairing the first session of the day, and there are an interesting three set of talks that are lined up for the day on introduction to analytical and applied pyrolysis and some applications pertaining to failure analysis and applications in polymer processing. Without taking much time, let me invite the first speaker of the day, that is Dr. Michael Soll uh, from the Frontier Laboratories, Europe. So he studied biology and received his PhD in 1993 at Ruhr University, Bochum, Germany. He has over 25 years of experience in business development, marketing, and sales at various companies. His functional experience includes, the sales of LC and GC coupled MS, MALDI-TOF, MS, and chromatographic tools. Since 2014, he's with Frontier Laboratories, taking the analytical pyrolysis, and he's mainly involved in supporting the partners and users of analytical pyrolysis in Europe. And so he'll be talking to us about, and he'll be giving a brief on the introduction to pyrolysis, GC mass spec as a technique, and some of the recent developments. With this, the floor is yours, Dr. Soll. And before you start, let me also ask the participants, if you have any questions, you may post your questions maybe in the chat box, and we will have a good 30 minutes of discussion towards the end of all the three talks, where we can actually discuss in detail.
Okay, thank you very much. So I will...
Over to you, Dr. Soll.
Yeah, thank you very much, Professor Vino. I will now start my presentation, but I will now switch off my camera. You have seen me. And to start it. So let me share the screen. I hope you can see the screen. Can I get
yeah,
right?
Yeah, all good, yeah, all good to go.
Everything working. So just in case, oh sorry, just in case I'm just looking for the laser pointer. Now, okay. So again, hello, good morning, good day, and good afternoon all together. So first of all, Professor Vino, again, thank you very much for your kind introduction. So, and in my presentation, I will give a brief introduction of Frontier Lab and the Frontier Lab's PyGCMS solutions and developments. So this is a presentation outline. So after introduction of Frontier Lab, I will talk about PyGCMS and analytical methods. After this, I will give a product overview and introduce briefly our accessories, the ultra-alloy columns, and also briefly about magic chemisolvers. I will finish with our database software introduction. I will show just one slide per product to stay in time and to mention the most important things. Otherwise, I can speak for hours here. So if you are interested to get more details, please let us know. And I think applications and many of these products will be part of the following talks anyway today and also tomorrow. Well, there was already a brief introduction, but I will do it again here. Let me briefly introduce the company Frontier Lab again, which I represent in Europe, as already mentioned. So Frontier Lab is a Japanese family-owned company located in Koriyama. which is about 250 kilometers northeast of Tokyo. You see the map. Frontier Lab was founded 33 years ago by Dr. Chuichi Watanabe, and currently there are 57 employees, while 8 represent Frontier Lab in various countries and territories outside Japan, and they are located in China, in Russia, India, Singapore, USA, and Germany. So that it's me. And in the left upper corner, you see our new main building here, opened in 2016. In addition, we have a separate building for R&D. And our CEO, you have seen him already, is Dr. Atsushi called Ichi Watanabe. So Frontier Lab is a manufacturer, as you heard already, of analytical pyrolyzers, microreactors, and ultra-alloy GC separation columns. And we see ourselves as a world leader in analytical pyrolysis. And we do actively participate in scientific conferences around the globe. And our main focus and expertise is the polymer characterization with pyrolyzer and such analytical methods, what I will explain later, like EGA, thermal absorption, reactive pyrolysis, and so on, but also the fast catalyst characterization with microreactors, which are also based on pyrolysis, of course. And tomorrow we will hear more about this topic and this technology. So start from the beginning. So this is a diagram of the multi-shot pyrolyzer installed directly on the split-splitless injector of a GC inlet without any transfer lines, which has a benefit that any cold spot can be avoided. The hard piece of the pyrolyzer furnace is a ceramic heater, allowing temperatures from close to ambient to 1050 degrees Celsius. The carrier gas flow, mostly helium, is connected here. So you always have a gas stream from the top downwards. This here in blue is a sample cup in a waiting position attached to the manual sampler. But of course, I will have the auto sampler, and I will introduce the auto sampler soon. The pyrolyzer can offer not only flash pyrolysis, called single shot, but also thermal desorption method due to its programmable oven. The combination of thermal methods like thermal desorption, pyrolysis, and so on is very useful and will be explained later in my presentation. Basically, the sample cup always falls from ambient temperature into the preheated area. And here the interface heating minimize cold spot at the interface between the oven and the GC inlet. And this allows for detection of high boiling pyrolysates of carbon numbers even above 100 C. Here in the left corner, you see pictures of our sample cups, which are made of stainless steel, but inside they are deactivated by a quartz layer. Some fundamentals of pyrolysis, although I'm sure that you are aware of these basics, but anyway. So if you burn if you pyrolyze or burn pyrolyzed butane gas, here's just as a simple example under air, it turns into CO2 and water. And of course, that would be not so helpful if you do it for polymer characterization. So, but on the other hand, using inert gas like helium, it is broken by the heat impact into smaller molecular structures like this. And if a big polymer like polyethylene is pyrolyzed, it's going to be broken into many smaller molecular structures. These are some examples for typical pyrograms. That means total ion chromatograms after PyGCMS, so we call it pyrogram. This is a pyrogram of polyethylene, what I have just mentioned, or let's say introduced before. And these are pyrograms of polypropylene, polystyrene, and the higher metacrylate copolymer. And each of the polymer gives a specific pattern. This is important, what we can clearly differentiate and consider as kind of fingerprint, if you want, like a human fingerprint. And depending on the polymer types, the pyrograms show unique and reproducible peak patterns at standard conditions. Coming to where are our pyrolyzer systems used? So the application areas of PyGCMS are really diverse and cover a wide spectrum of fields, from the characterization of polymers to environmental science. I think today and tomorrow we will hear talks related to these application areas or written in red letters. Microplastic, which is one of the topics, could belong to environmental science or could be also seen as environmental forensic application. So now let me introduce the analytical procedures that are possible with Frontier Lab multi-shot pyrolyzers. We have developed various analytical methods to cope with complex materials which can give complex and hard to interpret pyrograms like shown here. The first station is of this method map is the so-called EGAMS. Here, the sample is continuously heated in the Pi oven at a certain rate, for example, 40 to 600 degrees Celsius, while the GC oven is at constant temperature, e.g. 300 degrees Celsius. In this method, a short deactivated capillary, there is so no separation phase, is installed in the oven, so there is no chromatography and no separation. And with the MS detector, you get signals corresponding to the respective boiling points of these compounds contained. So at lower temperatures, the volatiles will be detected, and then at higher oven temperatures, high boiling materials are detected. And this thermal profile allows statements about the composition of the material, the complexity, and also the optimum pyrolysis temperature. To implement TD-GCMS or PyGCMS or combination of these analytical methods, so we are on the right-hand side here, GC separation column is then installed and a GC oven program is used. Pyrograms of TD-GCMS chromatones are then obtained, or a combination of thermal resorption followed by pyrolysis. We call it a double shot technology. Hard cutting is a thermal slicing of the thermogram. So in this example here, we can hard cut fractions from A to E. So up to 8 steps are possible, and selective sampler, which I introduce later, is a great tool to perform this hard cutting automatically. So I like this picture here. So this is a total image of our multi-shot pyrolyzer with main peripherals and some consumables. You can see adding the manual pyrolyzer to a GCMS is just the beginning. The PyGCMS can be equipped with various accessories and software systems which improve significantly the applicability, the performance, and sample throughput. On top, we offer also a series of ultra-alloy columns and so-called magic chemisorbers, which are thermal extraction elements. And in the following, I will briefly introduce all these products. For time reasons, I won't speak about the manual sampler, sampling tools, and also I leave out the PyData book here. So I start with the vent-free adapter. The vent-free adapter is a very useful interface which allows switching separation columns without breaking the vacuum. In the case if you use an MS as a detector. So our vent-free adapter has a very simple construction. So the vacuum is basically maintained by this narrow resistor tube. And the vent-free adapter always stays inside the GC oven. You can easily change between the EGA tube to generate the thermograms and any separation columns. This means that the vent-free is nicely supporting the combination of analytical methods when you change between EGA and separation columns in your method map, in your workflow, and is avoiding downtime of the instrument. The auto-shot sampler, which is next, is a very popular accessory. And it is a device to introduce samples to the pyrolyzer automatically. So you see the mainframe here and the pyrolyzer at this position or here. At most, 48 samples can be analyzed automatically, and all analytical methods are supported. The sample cup introduced into the pyrolyzer furnace will be blown up and ejected by the recovery gas, and they are ending up here. In the case of we use MS as a detector, we use the same type of carrier gas, for example, helium. And the new AutoShot AS2020E is the new model and replaces the AS1020A. The function, operation, and installation are almost same as the previous model. It has some improvements over the previous model. For example, this sample cup guide and also the digital pressure gauge of the in the flow controller, and is also smaller and lighter, providing some more space for other samples to be installed on the GC. Next is the microjet trial trap, and this is used for the purpose of trapping of sample compounds introduced in the column by cooling the tip of the column inlet with liquid nitrogen. So we can reaching up to 196 degrees Celsius. The MGT 2030 is a new model and comes with a new flow controller with a digital pressure gauge. So in the case of thermal desorption analysis, it's necessary to trap the sample compounds, especially the volatile compounds during the thermal desorption before the GC is started. So, and due to the liquid nitrogen, the result is a very strong improvement of peak shapes of compounds, which are eluted at low temperatures. Here you see the flow diagram. Gases nitrogen is coming out here and flowing through a thermal exchange coil, which is immersed in a liquid nitrogen in a dewar, and the gas will be liquefied and then reaching here the GC oven at this place. We call it the MG tube, and here you see the column, so the ultra-low column going through the MJ tube, and like other accessories, the MJT is also fully controlled by our pyrolyzer control software. The selective sampler, which I already mentioned, is used for hard cutting analysis, introducing only the hard cut thermal fractions. One, some, or all of the different fractions here is shown as an example here in this insert, in this picture. And this is a new version SS 2010, which comes also with a new flow controller and with a digital pressure gauge. The principle of operation is shown here. So in the sampling on mode, this valve here is closed and we have a normal flow path from the top to downwards, and sample is reaching the column for separation. In the sampling off mode, this valve here will be opened and a high flow rate is reaching this part here, and due to the pressure difference, the unwanted compounds, let's say the fractions, will be purged out and not reaching the separation column. So that means this is enabling, together with the AutoShot auto sampler, a fully automatic thermal slicing of this kind of complex thermogram for complex samples. The carrier gas selector shown here is basically a carrier gas switch box. You can select the carrier gas from with the front panel or by the control software after you connected two types of carrier gas to the device. And the carrier gas selector is often used, for example, by our customers in the tobacco industry, just to mention one example. The tobacco is burned in the presence of air before the carrier gas is switched to helium and the GC can be started. But of course, in this application, you would also need to have a cryo trap installed. Now, you know, sustainability is a very big topic today. And I think we also hear about this later. And the micro-UV irradiator presented here is a sophisticated accessory for accelerated UV degradation studies of polymers. So while outside exposure tests and climate chambers are used to see degradation effects in years, months, or in best case, if you use this climate chamber in weeks, we can evaluate the weatherability rapidly, so it means in hours, and obtain important data for material research and development very quickly. So the system consists of the xenon light source, here the optical fiber cable, and the UV sampler. There are basically two analytical approaches possible. First is the online degradation study. That means analysis of volatile degradation products generated in the process of UV irradiation. That means in statu nascendi. So traces of degradation products are often generated during this process of UV irradiation for several hours in air atmosphere. So it is possible to perform the qualitative and quantitative analysis of those chemical species by TD, GCMS after online cryotrapping of these products at the tip of the separation column. And the second is the analysis of degraded polymeric materials by UV-induced degradation. So there is basically a comparison of polymers before and after UV irradiation to see the structural changes of polymeric materials. In this chromatogram here, you see polystyrene before, here in black, and after just 1 hour of UV irradiation. So you see a significant change of the pyrogram. One of a very new development is the MFS 2050. So it's made for trace analysis application and was basically developed in the context of micro and nanoplastic research and contamination analysis of recycled polymers. So in the right corner, you see the MFS flow controller, and the main functions are splitless pyrolysis without any secondary reactions to increase sensitivity enormously. We can see now even nanogram sensitivity in, for example, microplastic research. So the problem is, if you try to use the normal splitless mode using the SSL injector settings, the flow rate would go down to just 1 to 2 milliliter per minute, and compounds would stay long time in the hot zone, undergoing secondary fragmentations. In the case of the polystyrene, the trimer, the pyrolysis breakdown product, would almost disappear. However, the trimer is used for the quantification of polystyrene, for example, according to the new STA method for microplastics in water. As you can see here, the SSS, so the trimer, has almost the same peak abundance ratio in normal split and the new splitless mode using the MFS. So the second feature is the backflash function. So you could avoid that high boiling compounds, what you don't need for the identification and quantification, are not reaching the separation column. This would increase the sample throughput. And as example, you see the effect of backflushing after a certain time during the PE polyethylene analysis. In addition, also what comes with the system, so to say, is solvent venting. So solvents will be vented by the system. And I just want to emphasize again, we consider this as ideal tool for microplastic analysis, forensic application, and contamination analysis. So, for example, in recycled materials, it's ideal for trace analysis. Now, come to something completely different. So the new IQ mill, the cryogenic mill IQ mill 2070, is the last device in my overview, and is finally a device which works completely without any pyrolyzer or GCMS. So a power plug is enough. In sample pre-treatment, as you know, grinding samples into fine powders can be time-consuming and labor-intensive task. So the IQ mill is a device that makes grinding quite a simple process. I think especially in microplastic analysis, pulverizing samples in a required is a required pretreatment for sample uniformity and homogeneity, and also good for better reproducibility. The features are shown here. So it is quite fast and efficiently pulverizing by this high-speed three-dimensional figure-8 motion. And you see that here. This is a diagram, a schematic drawing of the vessel, the milling vessel. Inside we have crushing balls, can be made from stainless steel, tungsten carbide, or zirconia. And Here you can put the milling the vessels here inside and fix it. And so the operation is very easy. And also, this is also a big highlight, is very silent instrument. So you don't need to have a ear protection, or you don't need to have a separate room for that. And freeze pulverization possible with a small amount of liquid nitrogen. So what we do is basically that we immerse the sample, the milling vessel, and the crushing ball, everything in liquid nitrogen for some minutes, and then we start the milling process. So also ecologically and concerning costs, it's a good thing that we have a low liquid nitrogen consumption. And if I say high speed, that means we can get a fine powder, or for example, even for PE and PP in less than 1 minute. So it's quite a unique new product for Frontier Lab. So now finishing this, let's say, hardware, now we come to some consumables, and third thing is the ultra alloy capillary columns. So maybe you don't know, but the ultra alloy column was actually the first product what was launched back in 1991 by Frontier Lab. And the big advantage of metal column is the excellent durability. So we are not having any polyimide coating, so the temperature stability is very high, and we can run GC oven programs more than 400 degrees Celsius. It's less sensitive to contamination, so we have basically 4 times longer lifetime than fused silica columns. So it's very resistant to thermal stress. So, and that makes it also possible that our cryotrap, which has this up to 196 minus Celsius, can be applied, and this requires also this performance. And other fused silica columns would be damaged, would be broken. And also mechanically, it's very easy to handle and to cut and so on. And we have many separation phases and dimension available, as well as de-evected tubes, for example, the EGA tubes. Magic chemisorber, what is that? Magic chemisorber are steerbar sorptive extraction elements, and they have a titanium open tubular design with an inert treatment, like also done in the ultra alloy capillary columns. And they are chemically bonded. They have a chemically bonded layer of PDMS in this specifications, or PEG on the outer wall. So PDMS, as you know, has a high affinity to non-polar compounds, while PEG has high selectivity to polar compounds like alcohols and carboxylic acids. So how to handle it? You can basically immerse them in the sample, maybe aqueous solutions, or do headspace of solids to extract the target compounds. Then using the pyrolyzer, multifunctional pyrolyzer, you can form PyGCMS. And the PDMCs are, as you can see in this table, available in 3 sizes, and you can select one that fits best your needs. Now I come to the final section, and this is about our database software products. Because, as you know, after obtaining your thermograms and pyrograms, you need to know what polymers, what additives and other compounds you have in your sample. So the F-Search system, the F-Search 3.7 is the newest version here, is an ideal tool for unknown polymer characterization and consists of the search software, the engine, and up to 4 libraries. So the actual version 3.7 contains 1,315 polymers and 590 additives. And as I said, comes with up to 4 libraries, which is the all-in-one solution then. On the left-hand side, you see the polymer EGAMS library and the polymer PyGCMS library, which are both entire information libraries. On the right-hand side, you see the two individual peak information libraries, the additives and polymer fragment library, additive and so-called pyolysate library. The search engine here mentioned in the middle runs a patented search algorithm using integrated stomated mass spectra. So it's also possible to hand over data directly from F-Search to NIST to search for other non-polymeric substances. Finally, we have a database and search software system for microplastic identification and quantification called F-Search MPs, actual version 2.1. The features are the quick identification of polymers or polymer types for unknown microplastics by a sophisticated search program, automated creation of calibration curve and the quick quantification really in less than 1 minute. It's a very fast algorithm. And the software comes with a library for the 12 commonly used and most abundant polymers what we unfortunately find in our environment. And the all-in-one version contains also other additives and pyolysates, so you can also identify other additives, identify but not quantify, and also other polymers which might be in your chromatogram. And if you order F-Search MPs, then in the package you also find our microplastic calibration kit, which now comes in two versions, so the microplastic calibration and the microplastic calibration standard L for low amount of polymers, for the creation of the calibration curve on the microplastic analysis. And the type of the polymers which are included also in the library and in the kit are listed here. And the trick is that we have diluted the polymers in inorganic diluents, either in quartz or in calcium carbonate. So with that, I have finished this product overview. This was my introduction to Frontier Lab and all the products, accessories, and software. Thank you very much for your attention.
Thank you, Dr. Soll, for a very nice introduction to the capabilities and products from Frontier Lab in the domain of analytical pyrolysis and also some of the applications.